Oh, hello. Oh, gosh. Sorry. Oh, and welcome back. So in the last video, we were just kind of talking about the basics of t-tests and the rules that go along with t-tests, and then some hypothesis testing. Oh man, and now we're going to be getting into an example. Now I'm going to be doing this in a few different parts because we actually have some not new material to learn, but some new methods in coding and data manipulation to kind of get the hang of. So we'll be doing this in a few different parts, and well, I suppose you'll see. So anyway, here is the example. So one day you're working on your Stat 3050 homework and somebody taps on your shoulder. You're freaking out because your doors are locked, and also it's Charles Darwin. Somehow, this person, Charles, old Chuck, has has time traveled from the 1800s to 2021 to ask you a question. And the question is, do you know how to visualize data and do a t-test using R? He's got some data and he needs to figure out how to time travel. So your job is to analyze these data that he just gave you. So he hands you a sheet of paper and it's data regarding some cross and self-fertilization of some plant, some pea plant, something like that. And he wants to show the greater vigor of cross-fertilized plants, right? So his claim is that cross-fertilized plants grow, let's say, taller than self-fertilized plants. Okay, and if you're a biologist, that might make some sense to you. If you're not, that's okay. So we've got this data, and we need to our first goal is to visualize that difference. Okay, and then the second thing is we want to test to see, on average, do all cross-fertilized plants grow taller than fertilized plants? Okay, dealing a lot with plants with t-tests. Okay, so here we go. So the first thing we want to do is visualize those differences, and we have done this before by using a box plot, not a there we go, a box plot. Okay, box plots. However, the way that data is stored, or at least the way that old Chuck stored the data, is not the best for us to visualize. We actually have to do some maneuvering to make our x-axis be the grouping variable and then our y-axis be the thing that we're measuring. Okay. Right now we just have two columns for our two different groups. Okay. So we got to figure out, how to kind of do that. So let's go ahead. I'm not going to show you this just through the PowerPoint. I'm going to actually do it in R. So let's just go ahead and get this going. So I've got my working directory set. I have come to session, set working directory, and choose directory. I've got all of my files here. You can see the stuff that we did in the past, some future stuff, but we're going to be working with this darwin.csv file. So let's go ahead and read that in. We'll call it plant. And we'll just do this read.csv because it's a CSV file. And then we'll go capital D darwin.csv. Read that in and let's see what we got. Okay, so we can either do head of our data set, and that's going to give us in the console the first 6, whatever. I actually just want to see the whole thing because it's not that big of a data set. There's only 15 observations for each group. And this is fine. This is the way that most data are kind of stored. We have the block number here just represents the kind of observation number, which is also kind of represented here as the row number. Whatever. We can ignore this for now. And we've got our two groups here. We have our cross-fertilized group and their respective heights of the plant, and the self-fertilized group and their respective heights. Okay. Now, you're probably wondering, well, how are we going to plot this? Because with box plots, we always had another column here of our grouping variable, okay? But right now, our grouping variable is split up kind of conveniently, at least for testing in a moment, into these separate columns here. But we need to actually turn these column names into their own column, okay, our own grouping variable. And what that's going to look like eventually is we're going to have a column here called whatever, we'll just call it type for now. and it's going to be cross fertilize 15 times. And then we're going to have another one, not another column, but kind of a break where it's going to say self-fertilized, and it's going to go down for 15 more observations. So what we need to do is first, we need to get these column names into their own column, and then we need to move at least one of these below the next sort of height measurements. So we then have one column of height measurements and one column of our grouping variable. And that's going to make plotting much, much easier for us. Okay, very cool. Very cool, we say. So how do we do that? Well, thankfully, we have the tidyverse to help us out. And what we're going to be doing, and you can kind of see it in the PowerPoint too, is we're going to be going from wide data to long data. Okay, so we're going to be turning these two columns into one big column that is longer than it is now, right? And that's kind of why it's called wide versus long. Okay, so how do we do that? Well, the first thing we want to do, at this point, you've got the tidyverse installed. So we'll go ahead and just call it. Got to do that every single time. No, not that. Not capital T, just lowercase t. My bad. Also, you saw that error. There's no package called capital T tidyverse. That's because, again, R is case sensitive. So we're just keeping that in mind. Okay. So what do we want to do first? Well, I want to make a new data set, and I want to call it, I want to specify that it's at least different from this data set that we have as far as the overall structure goes. So I'm going to call it plant long. You can call it whatever you want, but that's what I'm going to call it for now. And then it's going to get, okay, it needs the data first from our original data set, plant, okay? And that's just, we see that over here, that's our original data set. And then I want to do something to it. And this next kind of function here is it's not cryptic. I think there could have been a better word for it, but what we're going to use is the gather function, okay? And it gets 4 things within this function, 4 arguments, okay? We need to specify 2 column names, okay? One based on the length measurement and one based on our grouping variable. And we also need to tell this function what columns to grab, what columns to make a new column out of the column names. And then we also need to tell it to treat those column names as a factor, okay? And that's just so the computer understands that it's 2 different things, in our case, 2 different things, okay? And not just a big string of characters, okay? So how do we do that? Well, the first thing is we're going to specify what the key is going to be, okay? And this is going to be our, let me do this. This is going to be our grouping variable. The order that you do this in doesn't really matter. I always like to do the grouping variable first, the key first, and then we'll get into the rest. But just for kind of convenience sake, we'll do the grouping variable first. And we can call that whatever we want. We can call this whatever we want. We're essentially making a new data set with this function here. Okay, so we're going to be saying, okay, so it's the grouping variable. Maybe I'll call it group for now. Okay. And that's all. That is all you have to do. This is going to be the new column name for the stacked version of these column names. Okay. And then I come down here and make a new one. And then this is going to be, you guessed it, our measurement. And in this case, we're measuring height. So I'm just going to call it height. Okay. I could call it whatever I want. But in this case, this is going to be the thing we're, good Lord, measuring. Okay. Very cool. So that's 2 out of 4 things we need to specify. So I put a comma there. And then the next thing we specify is what columns we want to stack essentially on top of each other. Okay. And it has to be case specific. It's case sensitive, right? So we need to say, I want this column and this column. I want this column through this column, essentially. And so that just looks like there's no argument there. There's nothing that equals what I'm about to specify. It's just kind of blank. It's a little kind of confusing. It's not the same syntax as we're used to seeing here. But if I just say, and let me make sure I get the names correct. So it's capital C dot fertilized. So I say, okay, I want capital C dot fertilized. In fact, it gives it to me, which is nice because it knows that we're looking in this data set, which is great. And then I think it's self. Let's see if it figures it out for me. Yes, it does. Great. So that's what I'm saying is I want this column on top of this column, or this column on top of this column. I want to make these two columns one long column. Okay, and I'll show you. This is a little cryptic. I'll show you here in just a second. And then the last argument here is factor key equals, and then we want this to be true. Now this equals true. You don't have to type in true. You can type in capital T, and that does it as well. R is not too picky about that, but it does need to be all caps if you decide to do it this way. Okay. Oh boy, what the heck? So again, this is a little. I mean, it's a little complicated. I'll be totally honest. But as time goes on, this will become more natural to you. And also this kind of format that you see here is always true when we're doing this kind of stuff. So columns we want stacked. Okay, there we go. So we've got it all. We've got it all. And if I run this, check it out. So we have our same information here. All of our information is still here, except we now have a column of our grouping variable and the thing that we are measuring. This is very similar to the last data set we were working with, where in this case, or let's see, in that case, it was males and females in one column, and then muscle density and age in two other columns. Well, we have essentially just copied that same format, where we have cross-fertilized and self-fertilized, and then the one thing that we're measuring, okay, or the one thing that we'll be comparing here. Now, we use this type of data structure to plot, okay, to plot. For t-tests, though, we're going to be keeping it in this kind of structure. So long data is used for plotting, and then this wide data is used for testing, okay? Testing, plotting, okay? Because we need, for our plots, at least for a box plot, we need an x-axis that has this grouping variable and a y-axis that has our thing that we're measuring. Oh, boy. Okay. So we've got some pretty heavy data manipulation going on. This skill that you just learned here, this code, very, very important. Oftentimes, like I said, data is stored like this. Sometimes we need it like this. Okay, so it's the same information. It's just slightly structured differently. Okay. Now, oh man, let's make a box plot. Now you should have the code to make a box plot. So what I'm going to do is I'm going to pause the video and I'm going to write the code so you don't have to watch me do it. I recommend that you do it as well. The code will be the same as all the other box plot codes. We're just going to be using the long version of the data with the grouping variable on the x-axis and the outcome, the thing we're measuring on the y-axis. Okay, so with that, I'll be right back. Okay, I'm back. So I've got the code here. I haven't run it yet, but I just want to show you just kind of a recap what exactly we're doing here. So we've got the data, and it's our long version of our data because we need the grouping variable on the x-axis and the thing that we're measuring on the y-axis. And if I just run this by itself, Control Enter, booyah, right? So I've got the grouping down here and then the height here on the y-axis, okay? And then I need to run the error bar code, right? Because we work in layers here. So this is kind of the second layer on top of the first layer, the base layer. So I've got, those are the error bars, whatever. This is not, this is not a box plot. These are just kind of showing you the overall range. And then when I run geom box plot right next to it, it plots the box, right? And it also, in this case, we have two outliers in each group. We have one really small, really short cross-fertilized plant at about 12 inches. And then we have one really small or short self-fertilized plant at about, I don't know, 13, maybe 12 and a half, whatever. We'll get to that. And then I'm cleaning it up with theme classic and then adding and actually taking away one of the axis labels because it's a little redundant, right? And look at that. That looks pretty decent. Okay, that looks pretty decent. So if you go back to the PowerPoint, I've got some questions. So number of outliers, how many are there per group? Well, we've got one here in the cross-fertilized. We have a shorter than the rest cross-fertilized plant, and then the same can be said for the self-fertilized plant as well. Okay, so 2 total outliers, 1 per group. Okay, easy enough. Again, that's what the dots represent. The dots represent something that is kind of out of the norm based on the other 2, or based on the other things in your group. Okay, so both of these are kind of abnormal, at least statistically abnormal. Not an issue. Not an issue. We're not going to take these out or anything like that. We're going to leave them in the whole analysis because outliers kind of tell a good bit of the story as well. Now, the question is, are these 2 things statistically significantly different? Okay, are they different? Do you think that if we were to blow this up into all pea plants that are cross-fertilized and self-fertilized, do you think that we would see this trend in the whole population? Well, we don't have access to that data. It's impossible to calculate data for every pea plant that fits these 2 criteria. We have to make inference about the population based on our sample. And maybe by this, we may have a little bit of a difference. It looks like on average, or at least the medians here, are quite different between the 2 fertilization groups. It looks like sort of the overall trend here is that cross-fertilized plants grow taller than self-fertilized plants. They both have similar distributions as far as the overall kind of shape here goes. The medians are about in the same place relatively, at least relative to the data within each group. We have outliers in right about the same spot too. So this might be, this might be true across the whole population. Of course, we will not know this. We're only making some kind of guesses here. We won't know anything about the actual population until we do a proper t-test, which we will do momentarily. And I will see you. Oh man, I'll see you in the next one.